Hi, I am Maxim from Versa, and in this video we will learn about network obfuscation. First, let's define what is a network obfuscation. So network obfuscation is a technique that involves intentionally obscuring or hiding the structure and behavior of end users and applications. Let's take a look at this example. We have a user who is connected to a Versa SASE gateway with Versa SASE client application. This user trying to access internal resource in a private data center. As a basic technique that can be used to confuse intruder who can capture user traffic over the internet is to change IPsec VPN pattern of it. In this example, user is assigned with a fake IP address that is not routed in enterprise DC. The request to an application is also done with IP address that is randomly assigned by a Versa SASE gateway. Once the traffic reaches Versa SASE gateway, those parameters are changed. As a result, VPN pattern also changed for outgoing connection to a private workload. And it is just a basic part of it. Every day, even user access the same application, those VPN parameters will still be different. So, in a simple words, network obfuscation will enhance the overall security posture by strengthening confidentiality, integrity, and resilience of the network infrastructure. This technique will help in mitigating reconnaissance attacks. It will reduce attack surface and deter automated attacks. So let's go ahead and take a closer look at it. So technically, network obfuscation is a combination of multiple security features such as CGNet and DNS proxy, which are available in Versa security stack. Leveraging those features, we can create configuration that will eliminate similar VPN traffic patterns, and as a result, it will significantly complicate undesired actions planned by intruder. Is it sound cool? Let's take a practical look at it. So here is my Concerto view, and I have a user connected, which is myself connected to a London gateway. And also, as per diagram, I have an IPsec tunnel with my private data center. Over IPsec tunnel, I have also a BGP connection. And over BGP connection, I'm getting 192.168.10.0/24 subnet. This is where my test server with private application is located. I'm going here to my laptop, which has this SASE client connected with the London gateway. And now my tunnel IP address is 192.168.105.2. Let me verify connectivity with my application now. And please note that at this moment, I don't have any network obfuscation enabled. So I do ping my app.acme.com. And as we can see, I cannot resolve a name. So I'm verifying my DNS. And I can see that based on my SASE gateway policy, I'm using public Cloudflare DNS 1.1.1.1. And this public Cloudflare DNS, of course, does not have any idea about my private app. So therefore, there is a reason why I cannot reach to my private app. Let me log into my server. It's 192.168.10.5. Let me make it bigger. And I will run TCP dump on my server to verify reachability. ICMP, I'll use ICMP at this moment. And I will run a ping from my laptop. Okay, so I'm running my ping and I can see that request is coming from 192.168.105.2, which is my tunnel IP address. Let me go ahead and enable private application obfuscation. So for that, I go into configuration, real-time protection, and network obfuscation. And first, I will enable application obfuscation. For that, I will tick this checkbox, and I need to add my private application. At this point, I don't have any application, so I'll click Add to create a new. I say it is Private application and host pattern will be my app.acme.com. And protocol for connectivity, it can be TCP, destination port 5001. Will be my business application and application service. I can set a productivity and a risk for that, and precedence. By default, it can be 1 as my application precedence here. I click next and I give it a name, my private app, and click save. So I can add this my private app with FQDN as a host pattern. And now I can also add a resolver. So which DNS server I need to use in order to access my private app. So my DNS server is 192.168.10.5. And I click add this configuration under Concerto and click save. Configuration saved. And now we can go ahead and publish it. Once configuration is published, we can go ahead and verify it. So I will connect to my server first and run TCP dump. So I start TCP dump for capturing DNS request. And first what I will do a nice lookup to my app.acme.com. Now I can see that I again getting response from Cloudflare, what is syncing my laptop, and I'm getting IP which is 100.76.24.3. But when I go here, I can see that my server actually getting DNS request, and this is for my app.acme.com, and I'm providing him a response with my actual IP address, where my actual IP address is 192.168.10.5 for this application. Okay, so let me start another TCP dump for ICMP, and I will do ping my app.acme.com. As we can see, I am trying to reach IP address 100.76.24.3, and my server is getting response from my laptop, which is 192.168.105.5, and I'm giving him an ICMP response. So if I check my tunnel IP at this moment, I have it as for London Gateway 192.168.105.5. Next, let's go ahead and enable remote user obfuscation. I go to real-time protection, network obfuscation, and remote user obfuscation. I hit the checkbox and click save. Now we can publish it. And go ahead and verify. So let me first check ipconfig. And as we can see, now my IP address is 100.72.0.0. Let me try to resolve my app. And at this moment, my app is resolving again to a different IP address, which is 100.74.24.0. So once I start ping, after enabling TCP dump on my server, I can see that I'm getting response from 100.74.24.0, while on the server I am getting request from 192.168.105.3, which is a different IP address than my tunnel IP address, as well as I'm giving my response from my Versa DC. So my Versa DC is this interface, which is 192.168.10.5 10.5. And this is what we can resolve in DNS. So here is my DNS configuration. Any request that is coming to this DNS server, the result will be resolved to this IP address, while on the client it is different. And please note that my source IP address is changed, my destination IP address is changed, while DNS request itself is coming to Cloudflare DNS. For DNS, we can also validate this DNS proxy in Concerto logs. I can go to Analytics and I click Logs, DNS and DNS proxy. And for example, I can analyze this entry where I'm doing a request to myapp.acme.com. And the source address is 192.168.105.1 with a destination address, which is my private DNS. And also it was proxied, and this source IP address is my real client IP and destination is Cloudflare. So in reality, I'm getting the DNS resolution from my private server, and IP address of this private server is hidden. And request is also coming from a different IP address. So this is address that is routed inside my data center network. But this is my IP address that is assigned to my SASE client. With this, I would like to conclude on network obfuscation technique. I hope it was informative for you. Thank you for watching.